Assalamualaikum and hi everyone. I am Nur Hannan Binti Norman, third year student from Medical Physics. My matrix number is 22302921. I will be the presenter today for the topic Radium 226 exposure in hot spring at Ramsar, Iran.
Hello, I'm Jannah Abdullah, third year student from Medical Physics. My matrix number is 22304230. I'm your editor for this video.
Now, what makes Ramsar so remarkable? To answer that, we first need to understand what radiation really is. Radiation is not just about nuclear plants or accidents. It is a natural part of our world. Every day, all of us are exposed to natural background radiation from the sun, the earth beneath our feet, and even the food we eat. Most people receive about 2.4 millisieverts per year. That's considered normal. But Ramsar, the story there is anything but ordinary. Ramsar is a scenic city on the Caspian Sea, but it has a truly unique underground secret. The city is hot springs flow through rocks rich in uranium. As uranium decays, it produces radium-226, a radioactive element. This radium gets carried out by the hot spring water, and as the water cools, it settles into white stones called travertine. For generations, people in Ramsar have used these stones to build their homes, unaware that they were exposing themselves to extra radiation. And this exposure is not just a short-term event. It is chronic, ongoing, and woven into the community's routines year after year. So, just how high are the radiation levels in Ramsar? In some neighborhoods, particularly areas like Tarash Mahalle, residents are exposed to as much as 260 millisieverts per year. To put that in perspective, there is over 100 times the global average and far above the recommended limit for radiation workers. Even the typical Ramsar resident receives between 4 and 80 millisieverts per year, far more than most people worldwide. You might expect this much radiation to cause serious health problems, but decades of research, including research studies and reviews, have found no clear increase in cancer rates, DNA damage, or genetic abnormalities among Ramsar residents. In fact, about 90% of cytogenetic studies show no significant differences compared to other populations. Even more intriguing, some research points to a phenomenon called the adaptive response. This means that, over time, the cells of Ramsar residents may have become better at repairing DNA and resisting radiation damage, thanks to long-term, low-level exposure. So, what does Ramsar teach us? Chronic exposure to radium-226 from hot springs doesn't seem to cause the health disasters we might expect. Instead, Ramsar stands as a natural laboratory, challenging our understanding of radiation risk and showing us that life can sometimes adapt in surprising ways. Of course, that doesn't mean we should ignore radiation risk elsewhere. Awareness, regular monitoring, and ongoing research remain crucial, not just for Ramsar, but for any place where people and nature are exposed to a high level of radiation. The lessons learned here could even help us prepare for human life in high radiation environments, like future missions to Mars.